Right. So good morning, CSCI 173273. So again, this is our first online class for this semester. Right. So we will be discussing Hive, which is basically one of the tools in the Hadoop framework. But before we begin, let's look at, so I gave instructions, right, to download this package. So you can actually download this package here. Right. Let me share my full desktop first so that you can see. There you go. This is the full desktop. This is the current VM that I'm using. So please ensure you download Hive. So from the last exercises, you should already have Hadoop and Pig installed. Now we're going to be doing Hive for this session. So you can do a wget, etc. To download it. Of course, I won't download it anymore because I already have this installed. Okay. So please ensure you start to do that so that later on, when we get to that part of the class, you can follow. Okay. Now, in the meantime, we will now proceed with the class. So good morning, everybody. I hope you had a good week ahead. And unfortunately for the transport strike, we're now supposed to do this all online. Good thing the pandemic has allowed us to have practice for this, right? Okay, so let us begin, right? So first, we're going to be discussing Hive, right? So Hive is basically a tool used for big data processing. One of the key advantages of Hive is it basically allows us to do SQL type queries on Hadoop infrastructure. So far, we use tools like Hadoop streaming, for example, that requires you to write a mapper and reducer to process data. Then we use the tool like Pig, for example, that allows you to create a script to query or interrogate the data. Now, the most common way in which people do data analysis today is basically with the use of SQL. And basically Hive, which was started by Facebook, basically allows you to do that. Right? So Facebook invented Hive basically because they wanted a similar way of accessing their data, which historically they stored in Oracle databases before. So in the past, it would be stored in Oracle databases. The problem is the amount of data increased. They had 135 terabytes of compressed data at the time they invented Hive. Now they have way more than that. And they had to put in 4 terabytes of data per day. So imagine getting like 4 laptops worth of data per day added into their Oracle database. Clearly, it wasn't sufficient, or the Oracle database wasn't enough for that. And as discussed previously in class, Oracle databases are not bad databases per se, but they're what we call transactional. So they're designed for transactions, not really designed for data warehousing. That's why there was a bottleneck, for example, when using such databases. So they needed a system that allowed them to query the data, but without the overhead of being a transactional database or data store solution, right? So that's why they created it. But they wanted to invent something that allowed them to do the queries in SQL, right? Which was a problem before because the tools available, for example, by the base Hadoop ecosystem, even if they wanted to use it, was basically not SQL driven. So they were inspired by the schema on read Hadoop, which was invented already by that time by the folks at Yahoo, and the implementation of the MapReduce paradigm, which was originally invented by Google. Okay. So what is Hive? So Hive is basically a data warehousing framework built on top of Hadoop. So instead of building your data warehouse on a traditional transactional database like Oracle or MySQL, you will build it up on a platform like Hadoop. It provides an SQL abstraction. So it's not quite 100% SQL compliant because there are things that are unnecessary. For example, like the stored procedures are not as functional compared to a transactional database stored procedure, but all of the queries necessary or all the commands necessary to perform data warehousing activities would be available in Hive. Right? So at least that was the goal. Now, warehousing is because it's used for analysis and reporting. Notice it is not transactional. Okay. So the queries are basically compiled and run by the Hadoop Hive framework, Hive, and it's basically run on a Hadoop cluster. That's the traditional implementation for Hive. The Hive architecture looks like this. So on the right side, you will see the Hadoop framework, right? So notice it's the standard. You have your name node, your data nodes, you have your job tracker, and you have your task tracker. So a job is sent to the job tracker. The job tracker breaks it down to smaller tasks, which are executed by task trackers. And when the task trackers need to get data, they basically pull it from call the name node, which points them to the correct data node where they extract the data, perform their part of the transaction. So you do the map reduce operation. You map them, you reduce them, you exchange and sort them, and you send the results back to the job tracker. Now, this one is the main Hadoop framework. Then we have tools like Pig, for example, that can run on top of this. Or we can create Hadoop streaming jobs. So we can create mappers and reducers that get assigned to this. Now, once that's done, the jobs are returned back. Hive is slightly different because Hive is basically a full execution engine. It has a user interface, may it be a command line or an API that takes in the SQL query. The SQL query is sent to something called a driver. The driver runs, and all of these Hive components run on a, for example, Hive node, right? Which can be one of your Hadoop nodes as well. The driver will take the query, will throw it to a compiler that interrogates the metastore, which we will discuss later, to optimize the appropriate MapReduce commands, which are sent to the execution engine. Execution engine sends it to Hadoop framework. That means the job of writing mappers, reducers, and things like that is actually done by Hive. So Hive will take an SQL query, converts it into the appropriate MapReduce jobs, and sends it to Hadoop. Notice it is similar to Pig, with the big difference that you have a metastore, for example, that is already aware of there's a structure that is already in place for the data in the Hadoop file system. It's one. And at the same time, you create or you compile that SQL command into the appropriate MapReduce jobs. Okay? Questions so far? Hearing none. Okay. So we move on to the next part. So this is just a description of the components, as I mentioned a while ago. There's one concept that I'd like to introduce at this point called the SERDE, or a serializer deserializer. Now, a serializer deserializer is basically a Java object that converts data into the appropriate Hive rows. The thing about Hadoop, if you notice, you can put any type of data inside the system. You can technically put a CSV file, a Parquet file. When you were doing the sample map Hadoop exercise, for example, the jar, you notice that there is a data format called serializable object, for example. So those are the different types of objects you can store in a Hadoop cluster. Of course, we were using CSVs in our activity, but not all data will be in a CSV. They can actually be a JSON file, for example, as we will learn when using Hive, or later, or they can be a binary file. Now, this does not prevent us from processing them using an SQL-like interface as long as we provide something called a SERDE, right? So this is an object that allows you to deserialize the data from an object format that is different, that is accessible via Hive, right? So that's what a SERDE is. And later on, you'll see that there are various types of SERDEs that can be used to process data. So the data in a Hadoop cluster doesn't have to be TSV or CSV files. They can actually be any kind of file as long as you have a SERDE that can access them, then you can use Hive. Just for reference for the class, Hive is the most popular type of that's the most popular tool in the Hadoop framework. Majority of the world's Hadoop jobs today run on Hive. Okay, so the Hive data model looks like this. So basically, you have a table, you have partition, and you have buckets. So let us start with the table first. This is analogous to your database table. So for those of you who have taken a database class, this concept should not be new. There are two types of tables in Hadoop, what we call an internal table and an external table. The internal table is basically the data was loaded using Hive, right, and is accessed using Hive. While an external table is the data is actually outside of Hive. It can be in HDFS, for example, that is managed outside of, I mean, the file could have been created by another system, right? Then that file is being accessed within Hive. So for example, in our examples in this class, we're using CSV files, for example, that were created outside of the Hive ecosystem. We did not insert the rows using Hive. We created the file outside. So this is an example of an external table. Now, the reason why external tables are useful is because there's no conversion necessary. There's no loading into a Hive database per se. Hive itself can access it as long as the proper serde is available from external tables. Okay. The second key concept in the Hive data model is called the partition, right? This allows the system to prune the data based on a partition key. Now, what is a partition key? So your rows may have specific columns, for example, or fields, and each of these fields may be used frequently as a filtering criteria. So for example, the examples given here are date and time and the departments or product categories. If you are more likely, for example, to do a query within a department and not cross departments, then it makes sense to partition your database by department. So you create a department partition, HR department, programming department, operations department, right? Or if you're more likely to run queries by a different product type or product category. So for example, in the example data set we used previously, the Amazon products data set, there is a field called product type, right? Toys, wireless, etc. Okay, so those can be used as basis for doing the queries as well. All right. Then the third type is what we call a bucket, right? So within a partition, so you break tables into partitions to make them easier to query, so the queries are run faster within a partition because you keep the data close to each other. Now, buckets basically are smaller divisions within a partition because a partition can be quite large and it can be broken into smaller chunks to optimize the joins. Now, this is something specific to the Hive ecosystem, and Hive is the one that optimizes this, while tables and partitions is something that we create as users. Okay, questions so far? Good. All right, so Hive model looks like this, right? So this is a Hive model. So you have here on the left side your Hive system where you run the queries. It creates the execution engine creates the MapReduce jobs, submits it, right? But it takes data from what is called the Hive meta store. So your external table is basically just a wrapper on top of the data sets here. Your data sets here can be in various files that are supported by Hive. So for example, you can do CSV files, object files, even database files can be used as long as the appropriate serde is available. Then that appropriate serde allows that data from these files, so you don't convert them or load them anymore. There's just an external table configuration that's exposed, which I will show later. And that data is exposed, that metadata is exposed to the Hive metadata store, which can be consumed by the execution engine when creating the query. That's the reason why the queries can be optimized, because these execution engines have awareness of the data structure that is stored in the Hive meta store. Okay. So this is an example of a Hive data model. So we can have like a student database, right? So the table is called student details. It can have partitions here called by departments. So CSE, civil engineering, electrical engineering. So they can be divided partitions, right? So if you're going to run a query that is specific to, say, CSE, then at least the system can only pull the data within the CSE. Now, the Hive itself will optimize it and will break down the partition into buckets, which are groups of users. These buckets allow Hive, although this is an optimization by the Hive engine itself, to know, for example, if the data is in a particular node, and therefore can assign the mappers to the appropriate node to optimize the distribution of the queries. Okay. So here is what it will look like in the file system. So this is an S3 version, but it can also look like the AWS. So this is what it's stored in AWS today. So if you look at the Amazon reviews PDDS, this is the file we downloaded, right? So the file we downloaded that we used, we actually downloaded the US wireless. So the product category will only be wireless. But if you look at this particular S3 domain, you will see that there are partitions by product categories. Then the CSV files are inside them. And this is what I mean by external table. If you notice, the file is still a CSV. It was still in its original format. Okay. There are many types of formats supported natively by Hive, right? You don't have to create a custom serde just to support them. Hive by itself already supports them. So for example, text file, which is your CSV, TSV, are part of the text file. There's a sequence file, which you bumped into as part of the Hadoop examples lab exercise. There's an RC file, AVRO, ORC, and Parquet, which are optimizations. The problem with text files is they're usually not what we call partitionable. So they are not queried as optimally, for example, unless you use some of these other files. Now, AVRO, for example, is a file all optimized for ingest. If you use the Hadoop framework tools like NiFi, for example, or Scoop, they can write files into AVRO or ORC into your Hive platform. So if you're streaming the data in from another system, you can actually stream them into these files and they can be used by Hive. Now that's a more advanced use cases, but for now, we will just be aware that these file systems are supported. Now, not present here, so you will see, for example, JSON is not here. But since it's a very common file format, what happens is that there already is a standard serde, for example, for JSON, which is already part of general Hive distribution. So even the base Hive distribution already has a JSON serde. Okay, so let's take an example of the three most common Hive data formats because they are installed by default, right? So you have text file, which can be your CSV, TSV, and it can be compressed or uncompressed. There's a sequence file and there's an RC file, right? So the data type of the text file is text. It's generally row-based because each line in the file is basically one row. It's file-based, the whole file is compressed. That means if you need to only get one row in that file, you have to decompress the whole file, which is one of the major disadvantages of a text file. It's splittable, of course, by row, but it's not splittable after compression. That means you have to decompress the file first before you can split it by row. Now, the reason why this is important is queries do not need to access all files right away, right? I mean, all rows in a file. Sometimes you only need part of the file. But if you use the text file format, that entire file has to be decompressed first before the appropriate row is extracted, right? Then we go to the other formats, which is the sequence file and the RC file, which are similar, except that one is column-based and the other is row-based. Now, the sequence file is basically row-based. That means it's similar to text files. Each line refers to one row. The big difference between text file and sequence file is the compression is block-based. That means when I need to access a row in that file, I don't need to decompress the whole sequence file, but just a particular block. That makes it more efficient when I run queries on sequence files because I don't have to decompress the whole file. Now, if I need to decompress the file and I need to access all the data anyway, then the text file and sequence file performance will be the same, right? Then we take in the third type, which is the RC file type, which is basically column-based, right? This is more appropriate for columnar databases. Now, not quite Hive, for example, but usually RC file is used for HBase. So sometimes you already have data in HBase that you want access via Hive, then you can actually load the HBase data directly in Hive. We're going to be discussing HBase next meeting if we finish the discussion for Hive today. So that would be one thing we'll discuss next meeting. So HBase is a columnar database system running on top of Hadoop, quite popular as well, right? Questions on the three main file types. So you notice there are pros and cons of using each file types. Your data would probably be in a text file format if it was exported from another database, for example. However, if you can load the direct database formats, for example, RC file is the database format file for HBase, then performance is actually better, right? So that's why please take note that Hive is capable of supporting many, many different data formats. Okay, this is just a visualization of row and columnar storage, but we will discuss this in more detail next week. The whole premise for today is on the left side when you look at row storage, right? Every time you extract data, you extract the whole row. And when you want to search, you do search row by row. So if I say I want to find everybody with a particular last name, then I load row 1 first, then I look at the last name. Row 2 first, then load the last name, etc. While a columnar data format is when I say I want to search for a last name, I simply load the last name column, so it's very fast because it writes all the last names, and I search for it. Then I will query the appropriate first name, email, etc. from the appropriate columnar rows. The reason why columnar storage is efficient for certain use cases is if you have use cases that are primarily driven by index. So for example, user IDs or application IDs or email addresses are examples of unique indexes that can be searched quickly and whose data can be quickly extracted if you use a columnar storage. Imagine if you have user ID as a field in a row storage database, you have to search all of those rows first. You load the whole row just to look at the ID number. Then load the next row, look at the ID number. That's why performance tends to be slower for use cases like that. So if you have a use case that requires an index, columnar storage is generally requires an ID, a search ID as an index for search, and columnar databases are better. Okay. Also, the choice of Hive data formats matter in terms of compression of options. How far can you compress the data? So for example, text file can be encoded if the original size is 585. If you encode it using RC file, it just becomes slightly smaller because you don't really change the, how the data is structured, or it's not much more optimized. And it's still stored in text format. So that's the thing with RC and text. They're actually still text readable. You can technically open them with the text editor and see the contents, right? But the structure is different. RC files are columnar and text files are generally row-based, right? If you transfer them to Parquet, which is a more optimized format, it's a binary format. And that's the reason why you see here it's a lot smaller. And the new version of Hive, which is Hive 12, which is what most systems use today, there is a native ORC file format that even makes the data smaller. And the reason why they're smaller, again, is because they become binary, right? And the block sizes used are larger as well, which is good for Hadoop systems. Okay, questions so far? Good. All right. So just as a recap from our previous lectures, we did discuss the difference between traditional databases and Hadoop, right? One is basically built to be transactional, therefore reads must be as good as writes. While Hadoop is built for data warehousing use cases, so batch is fine, data warehousing is fine, and that's the reason why we have to optimize for reads. You don't have to do too many writes. And because of this, that's the reason why Hadoop systems are very good for warehousing use cases, and it's going to store a lot of data, but it may not be the best solution for transactional systems for now. However, modern Hadoop systems performance has been improved quite substantially that there are a lot of Hadoop systems today that are actually used for transactional data already. And HBase, which we will discuss next meeting, is one of those platforms that can be used on a transactional manner. But for us, we're talking about Hive, which is mostly used for analytics and data warehousing, which is the appropriate use case actually for Hadoop. Okay. So let's compare Hive versus a traditional relational database. This is probably what Facebook was thinking when they were using Oracle databases and they invented Hive. So for a traditional database, you will have what is called full SQL, or SQL 92 compliant, right? Then in Hive, you will have something called HiveQL that actually looks like SQL, but is technically a subset of SQL. Traditional databases are great for interactive or online use cases, while Hive is technically good for batch or data warehouse type analysis. Traditional database is schema on read. That means you have to design the schema up front. Then you have to write the data, then you have to read it later. In Hive, you notice the schema is only defined when you read this, because the data sets can be in any format. They can be text, they can be ORC, they can be SQL sequence file, and they are loaded via an external table, which you attach a serde, which is only executed when you query the data. Now, there are pros and cons of each. By creating the schema up front, that means every read is super fast, right? While if you do the schema later, that means you have to do the decoding of the schema as part of your query, which makes it slightly slower. But of course, Hive systems tend to be larger. That's why that performance penalty disappears. Of course, the scale of the data we store in a traditional database would be in terabytes, while in Hive, it will be in petabytes, right? Both can do distributed processing per se, but it depends, right, on the strategy for distributed processing. For traditional databases, for the mechanism is usually redo log file sharing, while in Hive, for example, it uses MapReduce, right? And Hive can run in thousands of nodes. Like the clusters we manage for customers here in the Philippines are all over 200 nodes, for example. While traditional databases, you normally run in the tens of nodes, if you're lucky. Okay. Great. So that is it for Hive and the introduction to Hive. So if you notice, it's an SQL-based platform, allows you to run SQL queries on many data, many times, types of data, different data formats, loaded in a Hadoop cluster. Right? So you're normally the data is stored in HDFS. Hive can be run interactively. The cluster is always running, right? And we can do Hive. Right, so question so far before we go through the installation and configuration for Hive in Apache Hadoop. Okay, so now let's start with that. So hopefully by this time, your installation is done. So let's see here. Oh, is this better? Okay, let's keep it. Okay. So here, I already have Hive. I already downloaded the Hive package here. See, I have Hadoop already installed. So let me start my Hadoop first. All right. So there were some of you who had problems, for example, with Hive, with Hadoop or Pig, because it wasn't shut down properly. So just make sure you start or stop it properly so that you don't get corrupted name nodes and data with the nodes. Okay, if it gets corrupted, you can actually reinstall the whole thing. But there are certain directories, for example, in the var directory folder, which I'll show you in a bit, that actually store some of the information. That's why deleting the folder is not sufficient. Okay, you have to actually delete those working directories also. Okay, so let's wait for it to load. All right, so resource manager, yeah, this is your job tracker, task tracker in the new MapReduce framework. And of course, Hadoop has evolved substantially since this course was designed. So there are also other frameworks such as Spark, which we'll be discussing later in the class. Let's see if my name node is working properly. Am I doing this correctly? See, so this is an example of a bad bad in installation here. See, so localhost 9000 failed. So if you look at the logs, so this is example of the things that are written in the var directory. Okay, so maybe it's not in var. So it is somewhere else. So let's look for it. So see, various versions put it in different places. And that's the reason why I can't just say it's in one place or another place. It tends to vary depending on the version. Let's look for it. So yeah, I have the let's write this root and transfer it to a different place. Around, there you go. Let's see. Around. Right, so we're looking for the files. See, Cassandra is there, but we're looking for the Hadoop one. Looking at log. So it's running, but there's an error. Okay, so this is let me find the log file first, because I cannot find it. Or unless it's also in home. Oh yeah, so the log files are here. So that one was probably a name node issue. Let's see what the issue was. So it said here, inconsistent state. Ah, yeah, so this one is an example of it probably did not shut down properly. So the name node is not running right now. So this is it's in safe mode. So for those of you who want to have a permanent TV, I have a video of that here and how to fix it in case you're looking for an example. So fixing Hadoop here. So I have a video here on Apache Hadoop on how to fix it if it's broken. Right, so you can look that here. In case you have time, if this happens to you, then you can look at here. Tayo, ayusin natin. Let's see. So first, let's see what. So it's not running. So here it placed it there. So these are the files that have to be deleted if Hadoop, breaks, right? So it didn't put it in var, but I placed it in temp. And these are all the Hadoop related items. So the thing here is that even if you delete the working directory, but these things are still here, right? So your name node data is here. right? So it's in use, so it's locked. And that is the reason why you can't just, if you just delete it, then it doesn't necessarily work. So let's see logs of the data node also. Sorry. See, so it's failing because it didn't start, right? So there is a running data node, but the name node is not failing. So let's see if we can reformat the name node. Sorry, safe mode pala. So here, this is PMR, not relevant for us. So this is the first step you can try. So we can see DFS admin. Let's see. DFS admin. Let's follow it. Let's try to leave safe mode. See the status. So in this case, it's actually not running at all. So let's try to start. Oops. Okay, so I'm trying to start it again, but it already started. So see, so this one, name node, try to start again. This is okay. I just wanted to see the start command, but so let's start DFS. So my name node wouldn't start. So let's just assume the worst case and it's broken. So let's stop all. Oops. Okay, so this is an example of cleaning it up. So let's do cleanup now. Let's do our Hadoop installation. Where is my Hadoop? Sorry, not Hadoop. Unless it's cached. So now we're forced to do if Hadoop is broken, although that video I pointed out has it also. So I'm just gonna do it for now. We have a broken installation, or I have a broken installation. And I should have checked this before I went to class, but at least now we can do it in this activity. So first off, we made sure it was all stopped, right? There's no Hadoop running. Then we can delete the temp directories, right? So all the Hadoop temp directories must be gone because the system will remember this, right? And we didn't install Hive yet, so I think there's nothing else. Okay. Then I will try not to delete this. There's no configuration here, so everything should still be working. I'll just follow the installation instructions again. Delete it should be okay. The SSH should be okay. Let's now format and the name node HDFS name node format. So we're reformatting it. Since I deleted that temp directory, all the existing files are gone, right? So that's why this is entirely new thing. Okay. So this is a newly formatted name node. Let's see. Okay. All right. So it created a new, so notice it saved it in temp. But since I deleted that, then there's no existing one. So it created a new one. Okay. Then we start DFS. Okay, this is to start the name node and the data nodes. Oops. So let's create our user folders. Once it starts, let's wait a bit. So I only gave this, I think, 2 gig of RAM. So it will take a while. So this one, since I quote unquote removed the installation, so at least now my, oops. So my HDFS is working again, right? So a while ago it was broken. I didn't bother troubleshooting N anymore. So I didn't create my home directory yet. So let's create it. So my username is WIY. Of course, you have to do that for your own username. So after I do ls, then I will not get the no such file or directory error anymore because I created it. Okay, let's do the test step. And this is not necessary anymore, but it's always good to check if things are working. Oops. Let's So full path. So just be careful about where stuff is located. They may not be in the directory that you are relatively looking in from. This one also. So this is the sample MapReduce application. Okay. And let's take a look. Should be in the output directory. It's the file name. Port 5 zeros. That's the output. Okay, so now I'm sure it's working. You can complete the rest like this one. We just have to start yarn because I already did start BFS a while ago. Okay, so this is how you fix a broken Hadoop installation. Now we can proceed to the Hive portion. Let me load the Hive. Instructions are here. If there are questions, just feel free to raise your hand at any time or
Sir,
unmute your mic.
parang
Yeah, go
I
ahead.
can't find the module with the Hive sa Canvas. Is it ano na published na?
What module?
The one you showed with like Hive here.
The slides? This one?
Yeah, parang they're not in my Canvas, sir.
This one?
Na the entire introduction to Hive.
Oh, there you go. It's not ano pala.
Okay.
There you go. Can you see it now? Oh no, why did it become
I'll check.
unpublished? Yeah. Okay. Let us.
Yes, sir. It's there na. Thank you.
Okay. I didn't know that it unpublished it because normally it's published by default. Okay, so the fixing thing is also found here. I will also post this video, but in case you're wondering that the whole instructions how to fix it, that's also here. Okay, so now we're going to install Hive. This is Hive getting started. Of course, it says install Java, etc., which we already did because we're using Java for Hadoop. Install Hadoop. Actually, fix the broken one. So at least you went through that. Now we will go through this one. So this is Hive. You just uninstall it and set your Hive home. We'll install it. So tar xbcf Apache, right? So this is just to uncompress Hive into the current directory. Right? So just take note the versions move up. They don't move up as quickly because we're using the older versions for this class because they're a lot simpler, right? The more advanced versions of Hive, such as Hive 12 and the new versions of Hadoop, are a lot more complicated and they have a lot more steps. So this is just basically to show you how it's done using the simpler versions. Okay, now that I have Hive there, I'm going to edit copy this and edit my bash resource file, create the Hive home. Okay, and okay, so basically I added this and added this, and I am running out of space. Let's see, and that's it, right? Then I have to make sure it's executed. So there you go. The next step is basically, I'm not going to build Hive from source, so that's not what we're doing. So we're going to run Hive. Okay. So first off, you need to create stuff in your HDFS directory for Hive. So I'll create a directory temp. So right. So this is where Hive will put its files. So this version of Hive, at least the one we're configuring, is going to use the existing Hadoop installation I have in this system. Okay, so user Hive warehouse. There's no Hive yet, so let's create Hive first. Then I'll create warehouse. Then permissions. I have to grant permissions to the group. That's group plus write, meaning group write. By default, group doesn't have write permissions to that because there will be many users, such as our user going to be using Hive. Therefore, we have to have permissions on those directories. Okay. That's just following the instructions here. This, we already did this. Then we run the Hive CLI. Okay. Right. and it should simply work. Okay, while that's waiting, this one is to install a client called Beeline, right? Now, Beeline doesn't actually, it's not necessary for at least the on-premise Hadoop, but it's a nicer interface than the default Hive interface. So some people like it better. And Hive 2 server is a server that allows you to access Hive from remotely. Here, so you see Hive here, right? It's already running. Okay, so that's it. That's how you install Hive. And the rest are just some samples you can insert. So show tables. Of course, there's no tables yet because we didn't install anything yet. Okay. Yeah. Let's see. So this is the disadvantage of running it in a small VM. Okay. So that's basically just installing Hive with Apache, the Hadoop, right? So not much to do. In this case, no metastore client. Okay, so maybe we really need to do because the last time we did this, Beeline was required. So the thing you're seeing here is because the Hive itself, we're using an older version of Hive, but the Hadoop, we're using the latest version. So there will be some differences in how this works. So let's create the schema. Default, I think, is Derby. To schema initialization failed, metastore state, because it already exists. Okay. And let's see if Hive server 2 will run it. All right. But yeah, we didn't install HBase yet. We're going to install that next meeting. Okay. Let me load another window. Because this is a server. So this will stay running like this. Then let's run Beeline. There's Beeline running. Server 2. Actually don't know where it's running. JDBC. Let's see. It will guess the port number. So this is the server. This is my client trying to connect to it. There. Could not open. I have to specify a port. Okay, let's see. Beeline port 10,000. Here you can do this one. So just slash. So I'm running it on the same machine. See, connect. I'm supposed to see it try to connect here. There, this is attempting. This is an error. The metastore is really problematic. Yeah, because I don't remember creating it. Let's stop the server for a while. So there is this file called metastore.db. Let's see where it is. So this is the hard part about doing these custom installations. You have to find where the stuff are. But again, if they say if you can do it here, then it'll be easy. See where content. Condition. Put it. Metastore. Metastore user hide. We create metastore. No, I don't want to. We're not using MySQL. Yeah, so every semester, they always change the format. That's why it gets complex. No, I should not do that. So let's see. Here it is, metastore DB. Okay, so let's delete it. And let's create a new one. So this is forcefully creating a new metastore. It's taking a while. Okay. Okay, then Hive server 2. This would be one of the more useful videos because everything that could go wrong went wrong. But again, this is really part of bare, we call this bare metal installation. You're installing it from scratch. In real life, when you actually go to work and you use these environments, there are installers and templates that actually do this for you. So this one is just so that, if you see these types of problems in the future, you kind of know how to fix them. So they don't normally, the thing about raw installations is that if there's a problem, they tend to happen right away, right? And the fixes are not always straightforward. Okay, and turn VLine. See, see this work this time around. It's still broken. didn't even try to connect console. Let's try. It's manually pointing it to the Hive 2 server. This is the Hive 2 server. Oh, there you go. Oh, no, failed. It's not allowed to impersonate anonymous. Oh, at least that's progress. Let's see. Okay. I have to specify a username. Okay, let's see. And it should be good by now. Oh, they specify the user. Unless they want it to be anonymous. This is new. So the old version didn't have any impersonation. So let's just do the Hive site. Okay. So it said Hive site. Let's create the default file. What is the parameter called? Hive server. Hive server enabled to execute. This is true. Okay. Then let's skip this. Start again. So we start to restart the Hive server. We set that configuration. We'll try to connect it. This must have been a new feature introduced last year. So every year they add new features. To disable the impersonation feature. Let's see if this one. works this time around. But it's not enough to impersonate anonymous. It is too false. I restart all Hadoop services. Okay. Okay. So let's stop this. Let's stop all. And we have to restart all Hadoop services. But let's do this now. Para sigurado. So we are editing it to allow to not do impersonation for site. No. So they increase the security of Hadoop by not allowing impersonations. But since we're the only one using this machine, it should be okay. Right? So we configure that to allow. So this is a security feature they added to Hive server. Of course, for us, we're not concerned about that because this is running on a single VM. Test. Always test Hadoop. So the nodes are running. We can test the nodes. Okay. Oops. It's redundant. HDFS, DFS, LS. Okay. So let's see if Hive server now will behave. So typing Hive server 2 runs the server. VLAN is the client connecting to that server. And the Hive server is the one that connects to HDFS. Now this one, this is the plain connection refused. Service not running. Because it's possible the server was not running it. There, it's already running. I'm not allowed to impersonate anonymous. It's no issue. I already did that. Do as The quality network. So let's see, I have some instructions in the sample file here. Let's have a look. So I downloaded this sample Hadoop file. Alright. This we don't even have to do anymore. This used to be a problem before. So deleted the meta store, created the meta store. Impressions file. Slow. Internet's a bit slow now. Hello, is it back? I mean, it took a while. There you go. So I ran Hive directly instead of using Beeline. Okay, it works now. So apparently the problem, so let's just do a recap. So the problem was the schema. So this one, this file, I deleted it, right? Then I did the schema tool type TV create. Then I ran Hive again. Then it actually worked now. So now we can proceed with our activity. So let's, in case you missed it because the internet was choppy, here is the course file. There is a sample file there called Hive. Where's that again? Hive processing impression logs with Apache Hadoop. Okay, so it's a query file, but in the comments are instructions on how to proceed. So again, we did this already, except we're using a newer version that has that impersonation problem. The Guava issues longer exists this. So just we didn't have to do because apparently the Hive version has the updated Guava that was used by our Hadoop. We're using Hadoop 3.334 and Hive 239. So these little issues have disappeared. But we have to recreate the meta store. That's what was broken a while ago. So we deleted the original meta store and we created a new metadata store. Now we will download the impressions file. Let me just check because I think I uploaded it already. Let me see. Oh, AWS S3 LS. Let me see what it looks like first. Okay, so I think I uploaded that already. Impressions. So that's that script here. No, I didn't. So I need to upload that pala. Let's see if I have another example. Okay, so let's download this. I'll download it for you in case you have no S3 because you may not have S3. Let's see what it looks like. 14, 12, 15. Let's just download like a day or two. I don't have exactly a lot of disk space, so let's just try to grab a bit. I will compress it for you, don't worry. Sync. I will stop it right away so that it doesn't download too much. I mean, you guys don't have to do this. So I'll do this for you. I'll upload the files so that you can have your copies. We just need a few. Where did I put it? So this is the Hive ads. This is impression data. So when people visit the AWS website, oops, that does not exist. Let's put it impressions. For those of you who have AWS access, you can download this yourself. But for me, I just downloaded a little bit so that we can process it. So about 1 meg's worth. Let us start it. Sorry. Balik tayo. Okay, C, create. Okay, let's pretend we're downloading from scratch. Upload here. And then upload HDFS directory. Oh no, internet's slow again. Hello, hello. It's like half.
Yes.
Parang nag-work na siya eh. Let's see. Maybe I will stop share, reshare. So I'm not sure where you guys got stuck, but let's start from scratch, okay? On the impressions example. Are you seeing the screen now? Not yet.
Yes, sir.
See this screen? Okay, so the impressions that tar I put here, this is the impressions. We're not using the GCP example. We're using the example here. So this we downloaded already. Right, so first download this one, right? Hive example processing impressions data with Apache Hadoop. Right, so download this, right? Then you should already have a copy here, impressions, right? So that's this, but it requires you to get the data from here. So since you may not have AWS installed, so I did it for you. So you can download it here. Let's download this, okay? So this is downloading. Oh, sorry. You should download it to the machine, your HDFS machine. So now it is in my local machine, right? I have to transfer it to my Hadoop machine. Ay, shucks. Right, so I transferred it to my Hadoop machine. So I downloaded it to my local machine first, then I transferred it to my Hadoop machine. When I look at the Hadoop machine, it should be there, impressions.tar.gz, right? So I can uncompress that. Okay. So I uploaded it to my VM, uncompressed it in the VM. Now there's a folder called impressions. Okay. Then I upload that impressions folder into HDFS. So HDFS, DFS, both. I hope my memory does not fail me on how this is done. And I should have an impressions folder in my HDFS now. Okay. Taking a while. Then let us see if it's there. Kung bagay talaga si Okay, so most of it should be empty except correct. Let me check. Oh yeah, it's empty. And there is naman a few. Yeah. We only need a few for this class, so don't need to have lots of laman. Kasi kung may laman yan, we're good. At least there is something inside. So now I have a folder in my HDFS called impressions where I uploaded the file. Now just take a look at the structure. This is an example of a CSV na log file siya. Pero naka-partition. These are example partition, DT time partition. This is what it would look like if you partitioned your data. Okay, but again, for this class, not too important, but just wanted to point it out. So next part of the activity is, let's upload also the script file. So what's the name of my script file? Script file is called impressions non-EMR. There you go. So now in my VM, the script file is also there. Where is that? There you go. Although you don't really need pala to, because you can run it in individually. Right. So we're done with this. We uploaded it to tables impressions. This one, to do this, right, the path has to be the correct path. So let me type that in first. It should be 9. Let's check if that's correct. Hive 2.3.9 bin share. Hello, share. It's not share anymore, it's lib. So so it's different every year, every version. So let's replace it. Right. So now I'm replacing it with the correct path of that particular jar file. So this is so that later on, when I execute Hadoop, it knows where to find that particular file. That's this step, right? Now here we just have to, I'll just explain. So this is what a Hive script looks like, right? So this is that H catalog jar. Let me edit it na lang. Let me edit the original version so that I can upload it to you. So edit natin ha. So the path was different. We don't need to do Goava anymore. No need to do this. Then this is 2.9. This is Hadoop. Although you don't need to do this anymore. Okay. Then we replace this also with the correct jar. Okay. Let's see what else we need to correct here. I didn't put in the folder logs. I put in the folder impressions. So again, lang yung impressions. Okay. So let's see. So we need to run this. So we can run it one line at a time. So let's run Hive. Hive. So this should work now. Okay. First command. Let's wait for the screen. It's a bit delayed. Okay. Still delayed. Oh, there you go. So this one says Hive's already working. So you can actually copy paste it line by line. Or actually not line by line, but command by command. So this one points it out to the Hive H catalog core jar. The reason why we have to do that is because we're going to use a survey that isn't standard, right? So at least resources were added. So that worked. Then this is how you define an external table. First, we delete the table if it exists. Because if we're going to do this over and over again, and especially if you guys do trial and error, it may fail sometimes. So check if it's there first. Then we're going to, this is an example of an external table. Okay. So let's look at this external table. Okay, let's look at that structure. And let's look here at the HDFS file. Okay, so HDFS. I don't remember which one had inside. Let's see which one had stuff inside. It's fine. Okay, this one. So let's look at the file inside so that we get a sense of the structure. So notice there are many text files inside. Let's open one so that you see what it looks like. You can do it. Okay. So this one shows you the context of each file. Notice it's a text file. So as mentioned a while ago, these are like the standard things supported by Hadoop. But if you notice, the structure is not by etc. So that's the content of the file. Now, if you look at the external table that we're creating, it's the external table here. So the first one is request time. This look like a request time, maybe. So request time. Where's request time? So one of the entries should be request time. A request begin time, right? ID. I notice this one cannot have map and fields can be in table, you need to sequence it. So we're saying that request begin time would be the first column, add ID will be the second column, impression ID would be the third column, and so on and so forth. So this is what this thing means. So it forces you to take that data from the JSON file and make it into a table. And this is how it's done, right? So you pass in the JSON serde so that you can decompose JSON files. You point it to the directory in HS. So you notice just point it to the directory. Then I also said that DT is the partition. So in this case, you do have a partition, which is basically, there's a delay in the screen. So a partition, that is a date time partition. So if you look at that impressions folder, there will be many different folders with DT in front. That means it's a partition. So that we can run. So let's do it. Of course, it would be nice to copy paste it in one go, but we can't. Let's create table. So we copy paste it. Okay. Session ID. So I copy pasted it all and it ran, right? But notice nothing was copied. The data wasn't moved from the log files to a new place. It was simply put that thing on top. This one forces the system to fix it, right? To make sure that the proper partitions are known and to validate if the JSON file really has those fields, right? So you notice it added the partitions. Now we can run our query at long last. So I just want to run how many entries are here. So notice it's an SQL-like query. It's a produce job, so it'll take a while. Right? So this is simply counting the number of rows. So in this case, we have 606 rows because I only copied 606 rows. So describe impressions. Right? So we can do many other things. So for example, select what's a nice so add ID. So I want to see how many times an ad came out, for example. Right? From impressions, group by ad ID, order by count. Pwede ba ganito? As order by descending. So that's a typical SQL query that will tell me what are the top ads, right? So here, you notice these are the ads and the ad ID, they only appear once. So you notice lahat ng ads only appeared once. There. These are the top ads. So this particular ad appeared 3 times, 2 times, 1 time. So that's that query. So again, you notice the data was in log files, look like log files here. Diba? So this could file invented by an system that you did not have to convert at all, and it was already usable in this platform. Okay, then I can run SQL on it. So imagine the power where you can get these megabytes and terabytes of logs, put them in your HDFS, just wrap an external table on top, then suddenly you can do SQL queries. This is the reason why Hadoop is Hive is still very popular up to today because of its ability to do that. Okay, that's it for Hive on-premise. Are there any questions? Because next we're going to do it on GCP, which is a whole lot easier. Okay, questions? Wala. Alright, so I will stop this properly para next session hindi ko na i-on ulit. Right. Okay, so we're done for the Apache part, and now we will move on to, so I will also upload the updated script here para, and I will replace the one here. And replace this so that, you know, the instructions. Oh, internet sucky again. Wait, how do I do that? Well, I'll replace it later. Okay. In the meantime, let's do this first. So Hive with Apache Hadoop, really hard. But you know, if you know how to do this, then you can do a lot more, right? Then now we will go on to Hive with GCP. So GCP is a lot easier because you don't have to install it. You simply use it. But you have to put the data in a cloud storage bucket, right? So in this case, cloud storage, GCP cloud storage. Then Hive can either be used interactively or via jobs. Of course, for this activity, we're going to do the job architecture similar to how we did it in Pig. And this is instructions on how to use Apache Hive on cloud dataproc. So first things first, the sample script. There's our sample script. Okay. Oh, I did not upload it there yet, but it's here. I'll upload it later. So let's do this Amazon sales because the data is all already there. Okay. So if we look at the Amazon sales script, this is similar to what you processed using Pig, right? So just make sure that the Amazon is uploaded into the address of the bucket below. So in this case, I use the bucket CSCI 173-bucket AWS. So let's just make sure this Amazon scripts file is there. So again, by now, this should look familiar. Okay, cloud storage, buckets. Okay, CSCI 173-bucket. All right. Too many people in the house. Okay, so this show me the buckets. Okay, so I created an AWS folder here, and I uploaded this wireless file here. Okay, so upload the file if it's not there. Upload the wireless file. Then my script, I also upload here. Right, so Amazon sales GCP Hive example was uploaded here. So those are the two things you must do. Upload this file, upload this folder, right? And upload this data file. The data file should already be there because we did it in the last example with Pig. We just pushed it into the AWS folder. So just a quick example here, drop table if AWS wireless sales exists, and you create a table. Now this one is not a JSON file. It's a tab delimited file, C/T. So this is simpler. You don't even need to do that, you know, the JSON stuff, right? So there's the JSON servos not here because it's a text file, although it's compressed. And this is how the columns are divided. Then this is the query that I will run. So in this case, I wanted it to return the top products, or product ID, product title, and the helpful votes. So how many people voted that that product was helpful to them. So it's like top products in terms of helpful. So I uploaded it all here. Then I go to the dataproc. This is fairly straightforward. Same as how it was done before. And I create a cluster. Oh, it's a bit slow. Okay, so here there should be no clusters. And just as a warning, if you have a cluster here, it eats up credits. So make sure you delete it after the job. But you don't vanish. Slow, 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 slow. Oh, there you go. All right. Then this case, you can leave all of that for now. Let's make sure that this is E. This E is easier to provision. Okay. For now, there's really no call optimization. We just need a generic cluster. The cluster is being created, right? We wait. So the only thing I changed was the node types, right? I mean the E types so that they're easier to provision. As mentioned the last time we used this, so the nice thing about the E types is that they, how should I say this? It uses any available type as opposed to specify, and there's a certain type that must be there. Well, that's loading. We go to jobs and we create the job. Okay. In this case, we create a new job and it's loaded. Type is a query file, and the query file is stored in GS CS. So in my bucket again. CSCI 173 dash bucket flush. And the name of the file is Amazon sales. Let's copy the file name. Ito slow. Sabi, bagal yan. Type it lang. Amazon sales. Ano ito? Amazon sales. This is the problem with GCP. It doesn't have like a picker that allows you to pick the stuff. Let me just check the bucket name. Bucket name is CSCI 173 dash bucket. Yes, CSCI 173 dash bucket. Okay, that's it. Then submit. So I pointed it to the script file. The script file was the one that pointed to the data file, and this should simply be running. Okay. So here we just wait. It's running. Here's the query. It ran fairly quickly. So now it's running the query itself. Of course, this should be fairly fast because it's like, I think it's a gig, if I remember correctly. But you notice the external table, defining the external table was super fast, right? Pointed to the external table and immediately worked. Then here's the actual query itself. That's taking a little longer because then that's where the MapReduce job is done. Right? Of course, as I mentioned, this is all running on, so the driver, the Hive driver, is the one who takes the job, and the one that passes it to creates the MapReduce to notice it's a lot easier than the on-premise stuff because you simply don't have to install Hadoop anymore. Okay. Let's see. It's taking a while. Did they say a gig isn't exactly small? So here the job was submitted to the Yarn cluster. So Yarn is the cluster manager for Hadoop 2. Right, so it's running it. The job running. There's still a bit that needs to be run. Okay, so unlike the impressions that was like 600K, this is about a little more than like gig. So was be able to compress it. Okay, this succeeded. Let's look at the output. Where's the output? Downloading completed output. Okay. There. So the output is device. It should be the same because I asked for this query in Hadoop exercise. So you notice the results are the same as here. It's on running Hive on dataproc. So it's not, again, it's not hard. It's like pig, you specify the script file, you upload the script file, you put the data in the right place, create the job, then you run the job. Okay. Once you're done, you see the result and you're satisfied, then you can shut down and delete the cluster. Okay. In this case, delete, not just stop, because stop will stop from incurring the costs of the servers or the compute engines, but will incur the costs of the storage. Deleting deletes both the storage and the compute engines. This is a major difference between AWS, because in AWS, when you use their steps function, which is similar to jobs, here you have to delete the cluster yourself. Okay? Questions? No questions. Okay, there's a comment. For those who if you still have like $20 or so, that's more than enough. Just make sure that there's nothing running in clusters, because that's the one that incurs the biggest costs. Storage costs, there's also costs in buckets. So if you keep stuff here, this also incurs costs, but it's not as, let's just say it's not as big. Right. So there's also cost. These things also incur costs. You can also delete them, but they're not as large, and they're charged on a monthly basis. So by the time the class is done, then we should be okay. All right. So I think we should not worry about that too much for now. All right. So that's it for Hive. So just as a recap, right? So Hive, again, this is using dataproc. Also here, but I walk through it. This we don't have to go through because we're not using EMR for this class. Okay, but it's here in case you want to do it. And that's it for today. Okay, so any questions? I think that's it.
Hello?
Then if there are any activities, just let me know. Yep.
Sorry, question lang po. Dun sa
Yes.
assignment 9, GCP pa ba kailangan
Or so in any platform you like. Okay. Hide muna natin mga to kasi hindi pa natin ginagawa, right? attributes. Here, 9 and 10 are or. You can choose. So GCP or Apache Hadoop. So it doesn't matter where you run it. You just have to run it somewhere. Right. Okay.
Thank you, sir.
Anything else?
Sir, will you be posting the recording of this lecture?
Yes, I will, but it'll take a while because it takes about an hour for yung encoding and stuff. But by the end of the day, it should be uploaded already.
All right.
Okay. Anything else for this is your last chance?
Sir,
Yep.
sir. Is assignment done by pairs, sir?
No,
Oh,
it's
okay.
individual. Yeah. Last time it was done by pairs because it was hands-on. It was done during the class. And now we're not physically there. So it's just better to do it individually na lang if you're gonna do it at home. Okay. All right. That's it. All right. So